starting to figure out the area of regular polygons today. So the first couple of slides here have a whole lot of vocab. These two, you know, the area and a regular polygon has equal sides and equal angles. And then, did you know that a polygon has a radius? And then it has an apothem. And I'm going to show you this in a picture. So the radius comes from the center out to a vertex. The apothem comes out from the center to the middle of the side. Then we have central angles. Formula for central angle is here. Again, I'm going to show you all this in an image so you can associate it. And then these are the formulas for regular polygons using the words apothem and side length and number of sides, but we're going to get to that after you see vocab. Okay, so here's the image. We have apothem is this line that comes down straight. Radius, it's just like the radius of a circle. Hold on. Change out of this color mode. It comes from the center to the vertex. So the apothem comes from the center to the side. The radius goes from the center to the vertex. The radius is always longest. Center, that one's easy. Just right there. N is the number of sides, just like it was before. S is the side length. So that is S. And P is the perimeter. So it's all the S's added together. So you have apothem, radius, and side length. All right, and then we have a couple formulas. Perimeter is just N times S, number of sides times the side length, because we're only talking regular polygons here. And then our formula for area is 1/2 perimeter times the apothem. Now remember there were two formulas here. 1/2 perimeter times the apothem. Well, 1/2 times S times N. No. S times N is the same as P, right? Sides times number of sides. So these formulas are exactly the same, except this one reminds you how to find the perimeter. Now, the other way to find area of these regular polygons is to just focus on each of these individual triangles. If you can find the area of one triangle, then you can multiply it by 1, 2, 3, 4, 5, 6 in this case, and find the area. Because it's regular, all of those triangles are going to be the same. Right here we talk about the central angle. That is just the angle that's formed by the radii. Not the apothems, just the radii. So in this angle here, where we have the apothem, that central angle is split, and it is split equally. So both of those are going to be the same. So that's half of a central angle. All right, here we have an equilateral triangle. So I reminded you that a triangle has 3 sides. A is still the apothem, R is still the radius, O is the center. 3 times S is the perimeter because there's 3 sides, and this is the same formula that we're going to use on any regular polygon. 1/2 times the perimeter times the apothem. Here's square. Exactly the same thing. Area is 1/2 times perimeter times apothem. All right, let's take a look at a sample problem. We have a regular pentagon inscribed in a circle. Identify the figure. So identify the figure, pentagon, because it has 5 sides. The center, a radius, an apothem. Center is, it's just the name of the point, point F. radius. There are two possible radii here. Pick one, either FR, segment, or FQ. An apothem is the line that goes from the center to the side. There's only one drawn here, and that would be segment FS. And then a central angle. There are lots of central angles. You could do angle KFL, or angle LFQ, or angle RFQ. There are 5 of them in this picture. Pick one of those. Use your angle symbols. Okay. For this problem, regular polygon is inscribed in a circle. Identify the figure. Okay. Go ahead and try that. Pause now. Okay, we have a 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a 10-sided figure. So this is a decagon. The center is R. Radii, there's lots to choose from. R to anything other than Y, because Y is not on the outside of the figure. It's not on the circle. Notice how our radii hit that circle. That's why they're called radii. Apothem, that's going to be your RY. And pick one of the many angles that does not include the Y. Angle G, R, F. R will be the middle letter of that angle. Okay, now we're going to find the perimeter and area. Okay, so we have an apothem of 4 units, side lengths of 5. So that makes perimeter easy. 5 times 5. Perimeter is 25 centimeters. Not squared because it's linear. You can do perimeter with the piece of string, so it's not square. Area. Formula for the area in a regular polygon. 1/2 perimeter times apothem. 1/2 times 25 times 4. So it's 2 times 25, so that's 50. Our area is 50 square units. See, that's not too hard. 1/2 times the perimeter times the apothem. The hard part comes when they don't tell you what the apothem is. Okay, well that's a duplicate thing. We didn't need the extra space there. Find the perimeter in the area of this figure. It's a hexagon with side length of 12. So my perimeter is going to be 72. 12 times 6. But here, that's all they gave us. They didn't give me an apothem. They didn't even give me a radius. So we need to do a little bit of work. So I'm going to blow up this triangle right here. So this side is 12. We have this red side. And that's all we know. Except we know a little bit more. In a hexagon, we have a central angle. Now, to get all the way around would be 360 degrees. We're going to go 1/6 of the way around, right? There's 1, 2, 3, 4, 5, 6 pieces. So we're going to take 360 divided by 6. And that gives us a 60-degree central angle. All of these angles are going to be 60 degrees, including this one that I blew up. But it's split in half, so it's going to be 30 and 30. Now, the apothem is at a right angle to the side. So are you seeing a 30 60, 90, right triangle? You should. Okay. So if I draw half of it, bottom is 12. X root 3, 2x. You can use trig here if you'd rather. The 6 is the short side because it's across from the 30. So my medium side is going to be 6 root 3, and my long side is going to be 12. So I go back to my original triangle, 6 root 3. So in a hexagon, they have that special relationship where the side length and the radius are the same. So a hexagon is actually made of 6 regular equilateral triangles. Okay, did I give myself? Yes, I gave myself extra space. So now we know the apothem, 6 root 3. Perimeter, 72. Those are the two pieces we need, because the area of a regular polygon is 1/2 times perimeter times apothem. Okay. Remember, in here, the 6 root 3, that's 6 times root 3. So I can do 1/2 times 6 times 72. So that's 3 times 72. Can't do that in my head. $216. So 216 times root 3 is our area. You don't have to be more exact like from that unless it tells you to round. You can just leave it in radical form. So we found our things, right? We found the perimeter, 72, and the area, 216 root 3 centimeters cubed. Perimeter is just centimeters. Okay. Here we have an octagon, 8-sided figure, radius of 6, length, side length of 4. Okay, so we don't know the apothem again. So I'm going to enlarge that red triangle. We know that the radius is 6. We know the side length is 4. That's a right angle. So this really gets split 2 and 2. What is a central angle of an octagon? 360 divided by 8. $45. So that means this is a 22.5 degree angle, and this is a 22.5 degree angle. So we're not using special right triangles because the 45 got split. So we do need to use trig here. We are trying to find that missing side, and we know this angle. I'm going to redraw my right triangle because there's too much going on. 22.5 I know, 2 I know. Oh, you know, we don't need trig. You could use trig, or we can use Pythagorean theorem. Because I know 2 of the sides, I just don't know the third side. So I didn't really need the central angle there. So 2 squared plus x squared equals 6 squared. I know 6 is the C because it's not touching the right angle. 4 plus x squared equals 36. X squared equals 32. So x is the square root of 32. Which does simplify to 4 and 8. And I know 4 is a perfect square. It simplifies to 2 root. And that simplifies to 4 root 2. Sorry, I'm going to do that so you can actually see it. 4 and 8, that breaks down, so I've got a perfect square there. 4 and 2, that breaks down. So I got 2 sets of 2 that comes out. That's how I got my 4. And there's one poor little 2 that has to stay in. So it's 4 root 2. All right, I've got a little bit more room here. So I know my apothem is 4 root 2. That was my vertical side in the triangle. Perimeter is 8 times 4, because there's 8 sides and they were 4 each, so my perimeter is 32. So area 1/2 times perimeter times apothem, 1/2 times 32 times 4 root 2. So that's 16 times 4. And we'll do it the other way. Half times 4 is 2. 2 times 32. I got 64 root 2 inches squared. Perimeter 32 inches, not squared. All right, last one. Regular polygon with 4 sides, so a square, inscribed in a circle with a radius of 10. Okay, so we know that these radii are both 10. That's all we know. So I'm going to blow up the triangle that we've got some information on. 10, 10. Okay. What is our central angle? Well, 360 divided by 4, that's 90. So these angles are both 45 degrees because it's a split up 90-degree angle, which tells you 45, 45, 90, right? So these two sides are both congruent to each other because it's a 45, 45, 90. So we've got x root 2. The x root 2 is the hypotenuse. That's the 10. So we have to get over. So we have x root 2 equals 10. Divide both sides by root 2. X equals 10 over root 2. Rationalized. 10 root 2 over 2. 5 root 2. So both of these pieces are going to be 5 root 2. So that's our apothem. But how long is the side of the triangle? Sorry, the side of the square. Well, it's 10 root 2 because it's two 5 root 2s. So our side length is 10 root 2. Our apothem is 5 root 2, which makes sense because look, here's your apothem. Here's your side length. Yeah, the apothem's half the side length in a square. Okay, we have a second slide for a little bit more space. If our side length is 10 root 2, then our perimeter is 40 root 2s. 10 root 2 times 4. Our apothem was 5 root 2. So the area of this square, using the 1/2 times perimeter times apothem formula, is so 1/2 times 40 times 5. 20 times 5 is 100. Root 2 times root 2 is regular 2. So I have an area of 200 meters squared. Now, that was using that formula. But we know that the formula for the area of a rectangle or a square is base times height. And we figured out that the base was 10 root 2 and the height was 10 root 2. So if we use the old formula, base times height, do we get the same answer? It's 10 root 2 times 10 root 2. Well, 10 times 10 is 100. Root 2 times root 2 is 2. So we still get 200. So multiple area formulas work. It just depends on which information you have. Okay. All right, so that's all the notes for SV or AV, whichever one we want to call it today. AV1. We're going to continue working on that assignment that we have had for today, and then we'll do some activities with this kind of stuff before we have our quiz. All right, I will see you guys in the meet.